I'm Steve Mann and this is Paper Classroom. Welcome to another one of our Fibres Unit tutorials. In this tutorial we're going to be talking about silviculture. Silviculture is really just a fancy word for the establishment and management of forests. You've got to be very careful how you plant trees in forests. If you plant too many of the wrong type of trees or not the right mixture, it can lead to land erosion and all sorts of problems. However, in this particular tutorial I'm going to be covering two aspects. One is a bit on the bioengineering of trees, what they do to make them grow bigger and better and faster. And the other is how do we manage the trees to get a sustainable regular income. So as you see there are 5 stages in the growth optimization of trees. The first stage is so-called province and family. So in other words, family, you choose a tree that has a lot of the characteristics that you want in terms of maybe lack of branches or fast growth or tall growth. And then you decide where in the world is it best to plant it, and you plant it in different parts of the world and see where you can get it to grow faster than where it is at the moment. So that's stage 1. Stage 2, hybridization. So you hybridize it with another species, you mix pollens, generate the seeds and see how those seeds grow. Do they grow faster or better? Are they worse? You choose the ones that grow, that show an improvement. Once you've got those saplings that show an improvement, what do you do then? You start to grow trees, and then you do what's called vegetative propagation. So in other words, you take cuttings from those. Those cuttings are then biologically identical to the parent tree, so you can grow lots more of exactly that same sort of tree. And when they start to grow, you can take cuttings of those and everything's got exactly the same sort of DNA then. Stage 4 is called micropropagation, and this is basically cloning trees. You can take part of a tree that you want, reduce it to individual cells that are all exactly the same, and then grow them first of all in sort of agar gel, and then you plant them out as saplings. And you can go to some of these forests where this happens, and when you look at the trees, every tree is absolutely identical. They've all got the same branches in the same place. There's obviously minor differences due to animal damage or human damage or insect damage, but by and large all the main branches are exactly the same. It looks very strange when you see forests like that. And finally, there's DNA manipulation. They do actually manipulate the DNA of trees to change things, change the characteristics. For example, if you're going to do chemical pulping, then you're dissolving away the lignin, and the lignin is a pollutant. So one thing that they try and do with the DNA of trees is get trees to produce less lignin. If you've got less lignin there, you've less lignin to extract, and therefore you've got less pollution. They do it so that the bark is more easy to take off, or they manipulate it so the tree has fewer branches. If you have fewer branches, you have fewer knots in the main trunk, and the knots are no good for anything. So they do lots of things with DNA manipulation in trees to try and improve things, improve the species for the paper maker. And having now established our tree, we saw in another table in an earlier video that some trees can have a cycle time of 90 years. 25 to 35 years is not uncommon. Somewhere between 8 and 12 in places like Brazil. is common, but it's certainly not unusual. But you can't just plant a tree and wait 20 or 30 or 40 years before you can harvest it, because you've got to eat, you need an income. So what people tend to do is to plant trees a lot closer together than they really ought to be, and then regularly they take thinnings, they take up some of the trees to make space for others, and that wood you can sell. And you can see here the sort of things that happen to a tree. Up to 46% of a tree will go to pulpwood and then on to make paper or board. Sometimes up to 46% will go for sawn timber. So that will make either construction wood for houses or something like pallet wood, for example. And the remainder may go to fuel. And as you can see from here, the sawmills, material that goes to the sawmills, they will generate material that will then also go to the paper mill. Either something like sawdust that can go to the mill for biofuel to be burned, or small offcuts and wood chips that could be processed and turned into paper. So just to sort of summarise this figure and make it a little clearer, when you harvest the forest, when you do the thinnings, the sorts of things that you can get is construction wood. Typically, construction wood is taken from trees that have a diameter of greater than 18 centimetres. So if it's greater than 18 centimetres, you use it for construction wood. If it's between 14 and 18 centimetres diameter, not good enough for construction wood, but it can be used for pallet wood. And if it's less than 14 centimetres diameter, then you would either send it for pulpwood or you would send it for biomass. You would send it to one of their wood burners for generating steam and then on to generate electricity. So that really summarises our dip into silviculture. I hope you found it interesting. Thank you very much for watching this video. Nice short one for a change. So please feel free to leave any comments, and I look forward to seeing you in another video.